So, how does your mind actually work? I mean, really think about it. For most of human history, that question was, well, a total mystery. Our thoughts feel instantaneous, right? But underneath the surface, there's this incredible, hidden world of complex processes going on. And this is the story of the scientific revolution that finally gave us the keys to unlock that world.
Think about this for a second. January 15th, 2009, U.S. Air's Flight 1549 loses both engines. The pilot, Captain Sullenberger, had mere seconds to perceive what was happening, pull from years and years of memory, calculate dozens of variables, and make a life-or-death call. I mean, landing that plane on the Hudson, that wasn't just skill. It was an absolutely incredible feat of cognition. So the question is, how do you even begin to study something that complex, that fast?
Well, that is the central question of what we call cognitive psychology. It's the science that tries to understand all that mental machinery. You know, how we take in information from the world around us, how we process it, and then how we use it to do, well, everything, from landing a plane to figuring out what you want for breakfast.
And to really appreciate how big of a challenge this was, we first have to get a handle on what our minds are doing pretty much all the time, completely behind the scenes.
I mean, right now, as you're watching this, your mind is doing all of these things at once. It's perceiving, it's paying attention, it's remembering, it's processing language. These aren't just abstract ideas, right? They are active, hidden processes running constantly. And for the early scientists, this was a massive problem. How on earth do you scientifically measure something you can't even see?
So let's look at how the earliest pioneers tried to crack this nut. These were brilliant people, for sure. But their tools for looking inside the mind? Yeah, they were pretty limited.
Okay, so back in the late 1800s, we get the very first attempts to actually measure the mind. You had guys like Donders, who was timing how long it takes to make a choice. Then Wilhelm Wundt opens the first ever psychology lab to try and map out the basic elements of consciousness. And then there's Hermann Ebbinghaus, who, and this is incredible, scientifically studied his own memory using just himself as a subject. Each one of them, in their own way, was trying to make those invisible mental processes visible. Just take Ebbinghaus's famous forgetting curve. He showed, with actual data, how quickly we lose new information if we don't actively reinforce it. You know, if you've ever crammed for a test, felt like you knew it all, and then a week later, it's all gone, yeah, you've experienced this curve firsthand.
But there was a big problem with these early methods, especially the whole looking inward at your own thoughts thing. It was just too subjective. You couldn't verify it. And that opened the door for a powerful new movement that basically just slammed the door shut on studying the mind itself.
This led to a huge shift in thinking, a new school called behaviorism. Led by people like John Watson and B.F. Skinner, they argued that real science can only study what you can observe. You can't see a thought, right? But you can see a behavior. So to them, the mind was this irrelevant black box. You have a stimulus, you get a response. And whatever happens in between, well, it just didn't matter. For the behaviorists, it was all about conditioning. It was simple. An animal, or a person for that matter, does something. If they get a reward, what they called a reinforcer, they're more likely to do it again. If they get a punishment, they're less likely. And that, they claimed, could explain pretty much all behavior.
And this quote from B.F. Skinner just perfectly captures that whole worldview. The mind is not a different sort of thing from the world of matter. In other words, there's no mysterious mind stuff. There's just a physical brain responding to the environment based on what it's learned. And for decades, this was the dominant view in American psychology.
But then, in the 1950s, things started to change. A revolution began. Researchers from totally different fields started finding things that this simple reward and punishment model just couldn't explain. That black box, it was about to be pried wide open. So the big question became kind of unavoidable. I mean, think about human creativity, or language, or complex problem solving. Can you really boil all of that down to just a history of rewards and punishments? The evidence was really starting to pile up that the answer was a big no.
And a couple of key pieces of evidence really started to show the cracks in the wall. First, you have the linguist Noam Chomsky, who pointed out that kids say all sorts of things they've never heard before. They couldn't have been rewarded for it, so they aren't just mimicking. Then, you have Edward Tolman's experiments with rats, which suggested something really interesting was happening inside their heads. Tolman's experiment was just brilliant. So, he lets a bunch of rats explore a maze. Later, when he blocks their usual path to the food, they don't just get stuck. Nope. They almost instantly take a new, efficient path they had never taken before. This was huge. It proved they weren't just following a simple script of reinforced turns. They had a mental picture of the maze in their heads, a cognitive map. They were actually thinking.
And right as all this evidence against behaviorism was mounting, the final piece of the puzzle arrived. From a completely different field. The invention of the digital computer gave scientists a brand new, powerful metaphor for what might be happening inside that black box.
And this was the big breakthrough. Thinking about the mind like a computer. You know, it takes in information as input, it processes that information using internal rules, and then it produces an output. All of a sudden, psychologists had this powerful new metaphor. The mind isn't an empty box, it's a sophisticated information processor.
This whole information processing approach gave psychologists a new language and a framework they could actually test. We can study how information gets encoded from our senses, that's the input. We can study what kind of computations the mind performs on it, that's the processing. We can study how it's stored as memory, and finally, how all that leads to a behavioral output. We could finally study the process, not just the end result.
Honestly, this one single idea, the mind as an information processor, like a computer, it changed everything. It created the modern field of cognitive science as we know it today.
The Big Bang moment for this whole revolution is often traced back to a single symposium in 1956. You had linguists like Chomsky, you had AI pioneers like Simon and Newell, and psychologists like George Miller, all in one place, suddenly realizing they were all working on the exact same problem, just from different angles, how systems process information. That's when the revolution really became official.
And that led directly to what we have today, this amazing, interconnected field of cognitive science. It's not just psychology anymore. It's this huge collaboration with neuroscience, computer science, philosophy, linguistics, all of them working together to figure out the mind.
And at the absolute heart of it all is this concept of mental representations. This is the data your mind works with. It's your memories, your knowledge, your concepts. It's that internal map of the world that Tolman's rats were using. It's the very thing the behaviorists said either didn't exist or, at the very least, didn't matter.
So think about the journey we've just taken. We've gone from believing the mind was totally unknowable to having a really powerful model for how it actually works. The cognitive revolution gave us the tools to finally look inside that black box. But the journey is far from over. The real question now is, what do we do with those tools? What are the next great unanswered questions, like consciousness itself, that we're finally equipped to start exploring?